All right. Here we are with this definition of the inverse function. So if we're given a function f of x, we say that g of x is the inverse of f, the inverse function of f, if these two things are true. If g of f of x, that function composition, if those just sort of cancel out to give you the formula is just x, and that's true for all x in the domain of f, and also f of g of x likewise is also equal to x for all x in the domain of g. So all numbers x that you're even allowed to plug in there. So if you look at these exercises here, that's what happened with all of these. These are all inverses. And for these ones, well, let's see. If we think about the domain of f and g, the domain of f here is all real numbers because you can take any number you want and add 7 to it. So the domain is all real numbers, and everything we did here works out for all real numbers. Like no matter what x is, x minus 7 plus 7 is x. Here, the domain of f and g are just all numbers except for x equals 0. So you're allowed to plug in anything other than 0 in here, and you'll get x out. And that's also true when you compose it the other way. So, yeah, so all of those examples are examples of inverse functions. So let's look at this. Our f of x equals x squared and g of x equal to the absolute value of x, are they inverses? Well, let's start with doing g of f of x. So I'll do g in green. And you might be thinking, well, sure they are. These are things that are made to cancel each other out. But we have to remember that these functions are both weird when you talk about negative numbers. And let's see what happens here. So first of all, I'm just going to write the formula, and then we'll think about negative numbers in a second. So f of x is x squared. So we're talking about doing g of x squared here. And g does the square root. So do those cancel out? Almost. Like we're used to just canceling this out and just getting x out. But let's remember what happens with negative numbers here. So if I'm going to take this and plug in something like x equals negative 3. What is negative 3 squared? It's 9, right? So this would be the square root of 9. And what's the square root of 9? It's not negative 3, it's 3. So these are not equal. So in fact, what this does, when you square something and then take the square root, it gives you a positive version of that x. So this is actually equivalent to the absolute value of x. It's not just x. So it turns out these are not exactly inverses. Because this is not, the absolute value of x is not always the same thing as x. Because if x is less than 0, if x is negative, the g of f of x will come out to be a positive number like 3, whereas x is a negative number like negative 3. So it doesn't quite work out. So yeah, they're not exactly inverses. But if you restrict the domain of f to only include positive numbers, so in other words, if you make the domain of f of x just be positive numbers, then the answer would be yes. But as it is, the answer is not quite. Okay, so that's a annoying thing that happens when you have even powers, like x squared or x to the fourth. And we've had to deal with that annoying thing about negative numbers squaring to only give you positive results in a lot of different ways in this class. So anyways, let's look at this example. We have a town's population T years after incorporation is given by this formula. P is f of t equals 30,000 plus 2,000 times t. Let's solve this equation for t to get a new function, t equals g of p. So what I want to do is get t by itself. And there's going to be some stuff being done to p that will get you that t. So to get this t by itself, I'm going to subtract 30,000 from both sides. First, that's going to give you p minus 30,000 equals 2,000 times t. And then we can divide both sides by 2,000 to get t by itself. That gives you p minus 30 grand divided by 2,000 is equal to t. And that's what we're looking for. This is our function g of p. So we could write this using function notation as, so in other words, what this function does is you can take a population, like maybe when the population is 32,000, and plug that in for p, because that's what p represents, is the population. And if you do that 32,000 minus 30,000 and divide it by 2,000, the result is going to be t. So what this function does is it tells you how to get the year in which the population is any number that you want. So it gives you the year in terms of the population. Okay, so that's the answer to part A. Part B, we want to see, is this answer the inverse of f of t? Well, let's see. If it's the inverse, this should be true. We should be able to compose these and have them cancel each other out. So let's do g of f of t and see what happens. So the f of t is still 30,000 plus 2,000 t. And that's what we're going to plug into this function g here. The g says to take the input, subtract 30,000, and divide by 2,000. That's what we're going to do with this. Let's think about what we're doing for a second here. When we take a number t, we're talking about a year. So maybe t equals 5 years after incorporation. When you do 30,000 plus 2,000 times that year, 30,000 plus 2,000 times 5 is going to be 40,000. That's going to give you the population after 5 years. So just the blue part here is the population after 5 years. And then you take that and you subtract 30,000 from it and divide by 2,000, that's what should just give you t. That's what this function does, is you plug in a population and the output should just be the year at that time. So that's what's going to happen here. The 30,000 minus 30,000 is going to cancel out. We're just going to get 2,000 t divided by 2,000, and that also reduces to just give you t. So yeah, those cancel out. What if we do it the other way? What if we do f of g of p. Let's see how that works. So again, what does g of p do? If we take a population at some time, plugging that into g of p should give you a year. The result should be the number of years after incorporation that the town had that population. Now, if you plug that result into f, we're going to take the year, plug it in here. This is going to give us the population again. So hopefully, just because of the fact that these equations are all equivalent, it kind of makes sense that we should get a result of p out. Because g of p tells you the year that you had that population, then f is going to turn that around and give you that population again. So anyways, let's work this out and make sure that that logic makes sense. The g of p is p minus 30,000. We're dividing that by 2,000. And f of all of this stuff, well, what does f say to do? It says to do 30,000 plus 2,000 times its input here, which is all of this now. And multiplying by 2,000, dividing by 2,000 cancels out. You get 30,000 plus p minus 30,000. The 30,000 minus 30,000 just gives you p. And so, yeah, that works out. They are inverses. So I guess the answer to the question is really yes. G and f are inverses. All right, let's look at one more example. So if n equals f of a gives the number of gallons n, so the output of this function is the number of gallons of paint, it doesn't say that, the number of gallons that are needed to paint an area of a square feet. What does the inverse of f do? Well, let's see. What we want to do is get some function g, say the inverse of f is g. That should be a function so that when you do g of f of a, the result should just be that area. And likewise, when you do f of g of n, that result should just be n. Okay, so let's see. What is this doing? We're saying f of a is the number of gallons of paint. So this is basically saying the same thing as g of n equals a. Because remember, we have that f of a and n are the same thing. That's what this does. So so what is this function doing? It's taking a number of gallons of paint as input, and the result is going to be how much area you can paint with that. Okay, so yeah, this function takes a number of gallons n and gives the area that you can paint with it.